Hi folks, so this is question 3. So there's a circle and it gives us a couple of the points on it. We've got a chord here and they're asking us ultimately for the radius. So the radius of the circle K. So if you can see it straight away, it's easy enough. So it's that red line there. That's the radius. So from C to B, or you could look at from A to C either. It's the same thing really. So we're going to be using Pythagoras in the end, but we need to figure out the distance from D to C and the distance from D to B first, but we can find out them easily enough. So D to B anyway is the whole length from A to B there, it tells us, is 4 root 3. So from A to B is 4 root 3. Therefore half of that will be the distance from D to B, so that will be 2 root 3. So that's easy enough. The other one then, so from C to B, they actually give us the two coordinates, so we can use the distance formula, x2 minus x1 squared plus y2 minus y1 squared. So that's in your log tables, that's just the distance between 2 points, or the length between 2 points in your log tables. So 3, 2 and 1 minus 2, so x1 y1 and x2 y2. So we have 1 take away 3 squared plus minus 2 take away 2 squared equals, so 1 minus 3 is 2 and square that is 4, and minus 2, so we get 16 there. So plus 16, so 4 plus 16 is root 20. And you can break that down. If you use calculator, you should get 2 root 5, I think. So that's the distance from D to C. So we can just use Pythagoras then to work out the distance from C to B. So C to B squared would be 2 root 5 squared plus 2 root 3 squared. So you can use calculator for these then. So if you square 2 root 5, you'll get 20. And if you square 2 root 3, you'll get 12. So add them together and we get 32. So that is what CB squared would be. So that's what CB squared would be. So therefore, to get what CB is, we need to just do root of 32. And you can use calculator again, or you can simplify the surge yourself. So you should, if you break it down, you should get 4 root 2, and then that's the final answer. That's in the form that they want. They wanted it in A root B, so 4 root 2. Right, so for part B then, the first part, so show that these two circles touch externally. So when two circles touch externally, it means that they touch at kind of one point, where one circle is barely touching off the other, so at one kind of point. So the thing about touching externally, I didn't draw these very well, but what you should know is that the two radiuses, or the radii added together, so the radius of the two circles, if you add those two together, that's the distance between the two centers. That should equal the distance between the coordinates of the 2 points, so of this point and this point. So if you use distance formula for this point and this point, the two centers, then that should be equal to the radius of the two of them added together. Radius of two circles added together. So if you can show that, then you've shown that they touch externally. So radii added is equal to distance between centers. So we need to find the radiuses, or the radii of the two circles anyway. So let's just find the radius here of C anyway. So the radius of C, so there's a formula there in your log tables, and it's, so R will be square root of G squared plus F squared minus C. So that will be, so G in this will be 2, because 2gx, so whatever's in front of the x is 2g, so g has to be 2. So we do 2 squared, and then whatever is in front of the y has to be 2f. So 2f is minus 2, therefore f is minus 1. So plus minus 1 squared, and then take away what c is. So c is 95, but so we're taking away minus, it's minus 95, so we're taking away minus 95, so we're adding 95. So this will give us what the radius is then, so it will be square root of 100, and that will be 10. So that's the radius of C. The radius of the other circle then of S, that's easier to see. So R, it's just going to be 5 there, because when it's in that form, it's in the other form now, so 25 there has to be what R squared is, so R squared equals 25, so R equals 5. So therefore our two radii are 10 and 5, so we do 10 plus 5, that's their two radii. The distance between the centres then we have to find as well. So the centre of the second circle of S, we'll call this one S and we'll call this one R, it doesn't really matter. The centre of S is easy enough to see, it'll just be the opposite signs of whatever is in here. So instead of minus 7 it'll be plus 7, and instead of minus 13 it'll be positive 13. So 7, 13, that's the centre there for S. The other one then, there's another, it's minus G minus F. So remember we said G was 2 because 2GF is the form in the formula, so therefore it has to be minus 2, and the minus F then will be it'll be positive 1 because F is minus 1, therefore minus F is is positive 1. So minus 2, 1. So the distance between those 2 points then, so minus 2, 1 and 7, 13. So we do 7, take away minus 2, so plus 2 squared, plus, and then 13, take away 1 squared. So that would be 9, so 81 plus 144. And we'll get square root of 225, which is 15. And then we, on the other side, we just had 10 plus 5, so that's obviously going to be 15. So we get 15 equals 15. So we've shown that the two radiuses added together is equal to the distance between the two centres. Therefore, they have to touch externally. Right, so for the last part then, let's just draw this out again. So our centre was minus 2, 1, that was S, and then this was C. So C had the centre of 7, 13. So we want to find the centre of another circle that touches it externally as well. So if you think about it, kind of a straight line through those points. So we just want another circle like that that touches it externally. So if you think about it, it doesn't matter. All we need is one point on this line. It doesn't matter where the point is. If the point was there, then it would make a it could make a big circle like that with the center touching it externally. If the point we pick is down here, then it still makes a circle where it touches externally. I'm drawing these circles very badly, but what we need to understand is that you can pick any point that's on this line. So you just need to pick any point on that line that contains the other 2 points, and you've got one. So, and it doesn't matter what one, you just have to pick one of them. So all we're going to do is we're going to find out the equation of that line, and then we're going to sub in some x value in and find the y coordinate. That's all we're going to do. So to find the equation of the line with those 2 points on it, we're going to find the slope first. So minus 2, 1, 7, 13. So y2 minus y1 over x2 minus x1, so 13 minus 1 over 7 minus 2 is plus 2. That's 12 over 9. That's the same thing as 4 over 3. So that's the slope formula. And then we're using one of the points to find the equation of the line. So we can just use minus 2, 1. And m equals 4 over 3. So y minus 1 equals 4 over 3 by x minus 2, so plus 2. Multiply both sides by 3 there just to get rid of that 3 on the bottom. It's just a trick. So 3y minus 3 is equal to 4, and then I'm multiplying into 4, so 4x plus 8. And then that's it then. You can just tidy it up a little bit. So minus 4x plus 3y is equal to 11. So that's the line. That's that red line that I drew there then. That's the equation of that line. Minus 4x plus 3y is equal to 3y. Yeah, is equal to 11. So all we need is we just need any point on that line that isn't one of those 2 points, that isn't the point 7, 13. So I'm just going to sub in 8 in for it. Actually what I can sub in is 0. Yeah, I can sub 0 in for x because that will give me the point. If you think about it, in between there is the point is minus 2 up to 7, so 0 would be around here, and 0 would just be a nice number to sub in. So let x equal 0. You can let something equal y either here if you want, it doesn't really matter. But if I let x equal 0, I get minus 4 times 0 plus 3y is equal to 11. 3y is equal to 11, so y is equal to 11 over 3. So the point 0, 11 over 3 is an answer. That's a center. So you might get different answers depending on what you sub in. You can sub in anything into that line there. You can sub in anything for x or y in and get the other coordinate, and then that's your center. So that's everything then for that question.